This is solving equations by graphing, so we're going to use our calculators to solve some equations. Let's take a look at number 1. X squared plus 3 is equal to 7. So first you take out your graphing calculator and you let this be equal to y1. And then you let this equal to y2. Right? And when you do that, you will obtain the following. 1, 2, 3, because this is x squared plus 3 translated up by 3. And our graph will not be the scale because y equals 7 would be somewhere up here. So we're just going to draw graph y equals 7 right here. This is the line y equals 7. And this right here is, we've called it y1. This is y2. And this is equal to x squared plus 3. So you can use your graphing calculator to find out where these two graphs intersect, and where they intersect is the answer for the x value, right? So this is an equation, x squared plus 3 equals 7. So we're setting y1 effectively equal to y2 and finding out where these two graphs cross, right? And we're using our calculator to do that. You can use your intersection function to do this, right? Okay, so whenever you use the intersection function in your calculator, and you can use Google or otherwise to find that, you will get, for this one, you will get minus 2, and over here, you will get plus 2 for the x values. Now, whenever you actually plug them in, for the x and the y, like whenever you use the intersection function right here, you'll get x equals minus 2 and y is equal to, let's see, well, 7, obviously. And so the x values are the answers, it has nothing to do with what the y values are. You want the x values of those intersection points. Okay? So then you use the graph, you use the intersection function again to find this, and you'll get x equals plus 2 and y equals 7, and this is the other solution. So there are two solutions to this equation because it has the square in it, right, the x squared. And you can check, in fact, that these do work out because minus 2 squared is positive 4 plus 3, and that is in fact equal to 7, so it does satisfy the equality. So, okay, then we have this one, x squared plus x minus 6 is equal to 0, and if we graph this one, we're letting this equal to y1. So this is the x and the y coordinate, the y x-axis and the y-axis. And when you graph that, you'll get something like this, right? And now you've set this equal to 0. Now you could type in y2 into your calculator, but there's essentially no need to do that because y equals 0 is just the x-axis, right? So you just need to find where your graph crosses the x-axis, and you can use your 0 function in your calculator to find the zeros of the function, that is where it crosses, where y is equal to 0, right? And so to save you the time of typing in y2 equals 0, and then using the intersection function, it might get sort of well, no, your calculator could do it just fine, but it's just as easy to just use the 0 function rather than the intersection function. And so this would be y1. Again, we don't have to plot y2. This is not necessary, right? And you will find that this value right here will be equal to minus 3. So this will be minus 3, y equals 0. And then over here, on the other side, you'll have x equals 2 and y equals 0. Right, so this point right here will be at minus 3, and right here, this point will be at x equals 2. Right? Okay, last one. X squared plus 3x is equal to 10, and we will get something like this. So we have x and y, and graph will look like this, and that will be y1 this side here, and then y2 will be this side. So you plot that, and this is just a line, right? So this is y2 is equal to 10, and then this one right here is y1 equal to x squared plus 3x. And make sure all of that made it in. Yes, it made it in. Okay, just checking the viewfinder. I have a television in the back to make sure. Okay, so we use our intersection function. For this one, we would use the intersection function. Forgive the fact that my line is not perfectly parallel with the x-axis. Of course, it's just the fact that I'm drawing this by hand. This x-axis would in fact be parallel with y equals 10, the line y equals 10. And this value will occur at -5, and this value will occur at 2 again, right? Now it's just a coincidence that I have x equals positive 2 for all of these. I in fact engineered it this way just so it was easier to remember. I engineered it so that there was always a root where x equals 2, just so I could memorize it, right? And then this one went -2, -3, -5. So -2, -3, -5, that is correct. So, okay, so for this one, x is equal to -5 or x is equal to 2. And you would report your answer like so. And for this one, you would report x equals -3 and x equals 2. And for this one, you would report these two answers. So this is or like this, okay? So the graphing method is a powerful method that will aid you in solving equations quickly on exams or otherwise, prevent you from making careless errors. So I encourage you to use it often. I'm going to step aside and give you a clear screenshot. Try it for yourself.